Hello Ace, this is RetroTK2 and today we're learning all about lambdas in C#. If this is your first C# video, I'd strongly suggest watching the series from the start. Card should be on your screen now. And if you haven't already, might I suggest downloading the channel files that accompany this video. Card should be on your screen once again. So let's get started. What is a lambda expression? Well, according to the Microsoft docs, a lambda expression is an anonymous function that you can use to create delegates or expression tree types. By using lambda expressions, you can write local functions that can be passed as arguments or returned as the value of function calls. Lambda expressions are particularly helpful for writing links query expressions. We'll talk about links query in a future video. To create a lambda expression, you specify input parameters, if any, on the left side of the lambda operator equals greater than, and you put the expression or statement block on the other side. For example, the lambda expression x equals greater than x multiplied by x specifies a parameter that's named x and returns the value of x squared. The equals greater than operator has the same precedence as assignment equals and is right associative. From now on, Ace, I will just be calling the equals greater than sign the arrow, since that's what it looks like to me. Lambdas are used in method-based links queries as arguments to standard query operator methods such as where. This next block, Ace, uses a links query example, but it is very useful, so I'm going to just blast on through it. As I said before, we will use links in a future video, so don't worry too much about it right now. When you use method-based syntax to call the where method in the enumerable class, as you do in links to objects and links to XML, the parameter is a delegate type system.func_t result. From our last video, Ace, you should hopefully recognize the func syntax here. A lambda expression is the most convenient way to create that delegate. When you call the same method in, for example, the system links queryable class, as you do in links to SQL, then the parameter type is a system.links.expression.expression func, where func is any of the func delegates with up to 16 input parameters. Again, a lambda expression is just a very concise way to construct that expression tree. We haven't used expression trees yet, and I don't really know if we will in this series, but perhaps for a future video we will look into them. The lambdas allow the where calls to look similar, although in fact the type of object created from the lambda is different. In the previous example, notice that the delegate's signature has one implicitly typed input parameter of type int, and returns an int. The lambda expression can be converted to a delegate of that type because it has one input parameter, x, and a return value that the compiler can implicitly convert to type int. When the delegate is invoked by using an input parameter of 5, it returns a result of 25, since 5 will get squared. Lambdas are not allowed on the left side of the is or as operator. All restrictions that apply to anonymous methods also apply to lambda expressions. We'll look at anonymous methods right after we've looked at these lambda expressions. Expression lambdas. A lambda expression with an expression on the right side of the arrow operator is called an expression lambda. Expression lambdas are used extensively in the construction of expression trees. An expression lambda returns the result of the expression and takes the following basic form. Input parameters arrow expression. The parentheses are optional only if the lambda has one input parameter, otherwise they are required. Two or more input parameters are separated by commas enclosed in parentheses. Very like our methods is. xy in the parentheses, arrow x equals y, and this will return a boolean value is. Sometimes it is difficult or impossible for the compiler to infer the input types. When this occurs, you can specify the types explicitly as shown in the following example. Int x, string s, all surrounded by parentheses, arrow s.length greater than x. Specify 0 input parameters with empty parentheses. Note that in the previous example that the body of an expression lambda can consist of a method call. However, if you are creating expression trees that are evaluated outside of the .NET framework, such as in SQL Server, you should not use method calls in lambda expressions. The methods will have no meaning outside the contents of the .NET Common Language runtime. This is just useful information, yes, but probably will never apply to us whenever we're using Unity. Statement lambdas. A statement lambda resembles an expression lambda, except that the statement is enclosed in braces, like so is. This looks very like a standard method is, except without the actual method name. The body of a statement lambda can consist of any number of statements. However, in practice, there are typically no more than 2 or 3. Very like so is. Statement lambdas, like anonymous methods, cannot be used to create expression trees. Do not confuse the lambda operator equals greater than, or the arrow, with the greater than or equal operator. Greater than or equal, of course. Type inference in lambdas. When writing lambdas, you often do not have to specify a type for the input parameters because the compiler can infer the type based on the lambda body, the parameter's delegate type, and other factors as described in the C# language specification. For most of the standard query operators, the first input is the type of the element in the source sequence. The general rule for lambdas are as follows. The lambda must contain the same number of parameters as the delegate type. Each input parameter in the lambda must be implicitly convertible to its corresponding delegate parameter. The return value of the lambda, if any, must be implicitly convertible to the delegate's return type. Note that lambda expressions in themselves do not have a type because the common type system has no intrinsic concept of lambda expression. However, it is sometimes convenient to speak informally of the type of a lambda expression. In these cases, the type refers to the delegate type or expression type to which the lambda expression is converted. Variable scope in lambda expressions. Lambdas can refer to either variables that are in scope in the method that defines the lambda function, or in scope in the type that contains the lambda expression. Variables that are captured in this manner are stored for use in the lambda expression, even if the variables would otherwise go out of scope and be garbage collected. An outer variable must be definitely assigned before it can be consumed in a lambda expression. The following rules apply to variable scope in lambda expressions. A variable that is captured will not be garbage collected until the delegate that references it becomes eligible for garbage collection. Variables introduced within a lambda expression are not visible in the outer method. A lambda expression cannot directly capture an in, ref, or out parameter from an enclosing method. A return statement in a lambda expression does not cause the enclosing method to return. A lambda expression cannot contain a goto statement, break statement, or continue statement that is inside the lambda function if the jump statement's target is outside the block. It is also an error to have a jump statement outside the lambda function block if the target is inside the block. Moving on to anonymous methods, yes, I wanted to cover lambdas first, of course, because, well, anonymous methods kind of just get replaced by lambdas, to be honest, but hey, we'll press on. In versions of C# before 2.0, the only way to declare a delegate was to use named methods. C# 2.0 introduced anonymous methods, and in C# 3 and later, Lambda Expressions superseded anonymous methods as the preferred way to write inline code. Like I said is. However, the information about anonymous methods in this topic also applies to Lambda Expressions. There is one case in which an anonymous method provides functionality not found in Lambda Expressions. Anonymous methods enable you to omit the parameter list. This means that an anonymous method can be converted to delegates with a variety of signatures. This is not possible with Lambda Expressions. Creating an anonymous method is essentially a way to pass a code block as a delegate parameter. The syntax is almost identical to Lambda Expressions is. The only difference is that you have delegate and you don't have the nice equals greater than arrow going on. Hopefully that shouldn't be that big a deal. By using anonymous methods, you reduce the coding overhead in instantiating delegates because you do not have to create a separate method. For example, specifying a code block instead of a delegate can be useful in a situation when having to create a method might seem an unnecessary overhead. Remarks. Then goes on to talk about the scope of the method ACE. It also says about the goto, break, and continue being an error if it's trying to target the outside block. All stuff that we've covered in the previous sections. Right, so an absolute ton of information there is, and let's see these lambdas in action in our code. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. We'll also be using Unity Spice for all our logouts. Yes. If you'd like to get it yourself, just follow the card on your screen now and the instructions afterwards. Right, so Lambda Expressions, yes, they are probably, well, I remember the first time I ever learned to use them, they were fairly scary and the syntax looked a wee bit weird, but they're definitely, as soon as you get a handle of them, yes, they become unbelievably useful. So let's make sure that we get these here down right. Okay, so let's create a var action and create our very first Lambda expression, which we can't do, of course, is because var will not work with our Lambda expression. Always good to find that out. So let's put in an action instead. Let's do system action, and as you can see, this is the most basic Lambda expression you'll probably be able to create. Is well, out of curiosity, no, stuff can't do it. Okay, so this is it. That's pretty much it. So if you wanted to go and create perhaps an action with a parameter, you could quite happily do that. Action int, and doing so allows us to write it like so. So now we can name whatever the actual int we want to use. So let's call this my int. And now don't forget you put in your arrow. And now you can either create a Lambda expression, which is one without the square brackets, or you can create one with the square brackets. It is completely up to you, yes, how you do this. I'm going to create a myint.log string. Excellent. And now that's okay. So we can write it like this with the square brackets, or we can, of course, write it like so, yes, if you want to. The square brackets just allows you to use multiple lines, yes. So if I was to go and try and re-add to this, it wouldn't let me do so because we've taken a new line and it probably won't even know what my int actually is. If we did actually want to create more logouts and strings, this is the only way to do it would be to create our square brackets first, our curly brackets, and then encapsulate all of the expression inside the square brackets, just like so. I would say the best way to treat Lambda expressions is just to assume, well, not assume, but treat them like methods. They are essentially methods. So anything you create inside the scope of this, say create I equals 0, will not be available inside our actual method. So this is completely fine to do. Or no, it's not. As you'll see, if I put in the I here, yes, I will not be able to log it out. I mean, I'm actually having trouble trying to even type it out, since just C# doesn't have a clue what it is. It doesn't exist inside this. One thing to note though is that if we do actually create I outside the scope, it will then be able to be accessed inside our Lambda expression as this actual value. So if I was to create this as 10, and we would say I dot toString, and oops, a little bit of trouble typing it out here is at the minute. So this will come in, and now this won't be 10, this will be whatever value I is by the time that we actually log out or invoke the method. Again, it's very like a standard method here. So if we were to do something like so, and we will put in 99 for my int, then it would log out I as 10. But if I was to go and change I to equal to 5 here, then it would log out 5. We can go and have a little look at that now, yes, just to even prove that that is the way it works. So after Unity is compiled, drag your game object, or drag your script onto any game object in your scene and run your game. And there we are, yes, as you can see, 5, 99, 99. So unbelievably useful. It's good to see that this is just pretty much exactly the way that we've invoked our actions just before, yes. I mean, they are still actions, let's not forget. And this, of course, won't do anything since it's just an empty method call. Now, as the documentation said, you can also use it with funcs if you want to. So let's put in a nice func string, and we will return a string, and we will call it func, just because why not? And now we can put in the brackets. Now, you don't actually need the brackets, it's important to notice that, or to note that, but for whatever reason, I just get into the habit of actually just putting them in. I just prefer to do it because it means that whenever I'm scanning down, I can go, oh, okay, this is a method. I know that this is a method. Whereas if it's like this, I just find it a little bit harder. But personal preferences, honestly, whatever you prefer, it's totally up to you, let's be honest. And then put in our return statement and return X. Seems fair enough. And you can even, because this is all in the same line Ace, you can do an alt and enter on the return and create it to an expression lambda, like so. Very basic stuff, Ace. So let's also go and call this. So func, and we will call this, whoops, new func. And then we will also put it equal to a string. Super basic is nothing that we haven't hopefully seen before. We borrow the Lambda expressions, of course, but the actual invoking of them, they're just standard actions and funcs. So really basic is, after it's compiled, we should hopefully see 10, 99, 99. All super duper. Okay, let's actually log out the string just to make sure that this all actually works. Rerun your game. And hey, new func. Easy peasy is, hopefully. Okay, now let's go on to something a little bit more complex. This was the one that's probably fairly important. I see it as self-evident, yes, but I suppose I could understand actually why people would get a little bit confused if they were just learning C# for the first time. So let's go and have a little look at this. So the doc said that you can't create a function expression or a lambda function expression, actually we'll just use func, that has continue, break, and return, meaning that you will come out of the actual outer function, as they called it. Here, I think return probably won't actually give an error since, well, since that you won't actually be able to, whenever you use return, it'll just return from the actual method. But perhaps they're sort of thinking if this method was an int return and then you tried to return an int from an action function, then they would probably, the assumption would be that the compiler would try and return the actual int here, and that's not the case at all. Is so here we go. I want to try and just prove that you can't use continue. So continue, as you remember hopefully from our loops video, continue will just loop this for loop anytime it hits this continue and won't hit this func block. So let's try and put in continue here, and as you can see, unresolved jump, because we don't have a loop here that comes straight out. But doing something like this will be completely valid. Is, and as you can see, we can actually reference the x of the for loop inside this function, which is kind of weird. Is so that's kind of cool. I'm almost curious to see what would happen if we do func here. I think the obvious that I can think of is that x will equal 9. No, x will equal 10. We'll exit the loop, and then here it should be okay. And this, of course, won't do anything. I'm not entirely sure why we're getting this error. I do know why we're getting this error, because we're not returning a string from our func class. Excellent. Okay, I really want to see this. So, oh, actually, well, there's a whole thing going on here, of course. So let's, it'll probably actually be 20. No, x will just exit. X should just exit, and then it should be equal to 10. This doesn't have anything to do with Lambda expressions, yes, but it's always good fun just to see how code actually flows. Or at least I think it's fun because, well, yeah, why not? Okay, let's have a look. I believe it's going to be 10. Let's have a look. And it is 10. Absolutely. Excellent. So as you can see, you can still reference it. And this x won't be garbage collected because, well, we'll not worry too much about garbage collection, yes, but this object wouldn't be disposed of. Although since it's a data type, they work a little bit differently anyway. We'll not worry too much about it, yes. But as you can hopefully see, that the continues needs to be used pretty much exactly as if it was a normal method, yes. This is it. Just think of lambdas as normal methods and you will be pretty much set, I think anyway. You can also pass lambdas to other methods if you want to, Ace. So say I had an action and I wanted to pass it as an action int, I could totally do that in my expression. So here we have the actual expression. We will use x, and x will be an action. Oops. I need to put in the arrow, of course, and we will of course be able to invoke x as if it was a standard lambda expression, and our lambda statement then I guess is what this is called, like so. So act, and then we pass in our lambda expression, which will be something like this. I'm kind of getting a little bit confused in what the actual syntax is here is, but no, I think I'm getting it now. Just be very careful whenever you're using these lambda expressions, because it can make your code a little bit more complex to follow, especially if methods are being called at certain points. And but yeah, it's unbelievably useful. It's class. So let's have a little look. Hopefully it should come up with 11 if we press play, and it does indeed, yes. So it's great that you can actually pass lambdas as parameters to other actions and other methods as well. And now, for the sake of argument, let's also just have a little look at delegates too. Let's make an anonymous delegate. I wonder if I need to, or an anonymous method, should I say, sorry. Int, since it's a real fun thing to do, delegate. Nope. And we will put in, oops, I haven't put in the actual act2, and we will have this as x. I can't have this as x, I will have this as p. Maybe I can't have this as p and I'm just being silly. Probably is, to be honest. Int p, there we go, and then, oh, okay, you don't even need to have that aspect to it. Ah, excellent. Okay, so you can just do p. No, you can't do p. Well, how do you actually, okay, interesting. Let's do int p. I'm just curious. I've never actually used anonymous methods before, so I'm very curious to see how you actually do this. Well, what would it be? Value would it be then, maybe? Value? Well, try value here. No, I have no idea how you actually would use the parameters on that one. Let's have a little look, sure. It's important to get the correct information for you, yes, you know me. I like to always make sure that, well, I keep as much information as I can for you. Maybe it's just because it wasn't being used. Maybe that's it. Yeah, that's probably it. Maybe. Who knows? Anyway, there you go. So this is pretty much exactly the same syntactically, we'll say, or in terms of outcome as this. The only difference being that the lambda expression is a lot nicer in terms of, well, in terms of just readability, I guess. Yes. Let's try this actually as a more fairer experiment with, like so, cat 2. Yeah, that'll do. Oh, nearly did it again. Excellent. And yeah, so there you go. As you can see, just a little bit more. And even if we did bring it in like so, yeah, I mean, your lambda expression is winning out there, yes. Let's, sure, for fairness sake again, yes, let's create a lambda expression, or not an expression, sorry, a lambda statement, like so. And yeah, much of a muchness, I suppose this is the only line that would be the problem, but I personally prefer this, personally. Although this more so with the brackets, I think it just makes it look, okay, I can see that this is a method. That is pretty much where I come from with this, yes. And that'll pretty much do us, yes. I think that's lambdas in a fairly good nutshell, and also anonymous delegates as, or anonymous method, should I say, as a nice bonus. So yeah, rate, comment, and subscribe, yes. I hope you're enjoying this series as much as I am. I'm having a ton of fun with it, and it's good that I'm getting through these episodes nice and quickly. You can email me at retrotk2@gmail.com if you're having any troubles with lambda expressions. Thank you for watching this, and I'll see you in the next video.